Okay, good afternoon, everyone. So, I'm very excited to be back with you all today. What we're going to do is we're now going to go over Chapter 9. As I've been telling a few of you that we are going to start new material. Um, Chapter 9 is kind of connected to what we've been doing prior with quadratics. We've actually talked about what we're going to talk about today before, but we're going to talk about it in a bit more depth and kind of give us a little bit of review so that we feel pretty confident moving forward. So I've attached a worksheet for you all to do. Please go ahead and bring that up, or if you could, print it out so that you can follow along with the video. So we're going to go through and we're going to start by talking about roots. Now, number one says fill in the blank. Well, we're given a really nice table. Um, we're given this really nice graph, and we're actually given the equation that everything belongs to, which is y equals x squared minus 2x minus 3. So what we're going to do, first things first, is we're going to fill in some of these blanks. The first one, vertex. Well, I know how to find vertex on a graph. I simply look for the lowest or the highest value. What I mean is the maximum or minimum. If we look at this graph, if we look and follow all the way down to this very point at the bottom, we know that this is our vertex or our minimum. So we can say that the vertex is 1 comma negative 4. And I know that that's just kind of review for us, so I can say our vertex is 1 negative 4. Now, our line of symmetry was always the x value of the vertex. Well, I can also draw in our line of symmetry just by saying, well, let's cut our parabola in half. So if I cut our parabola in half and draw a line down the middle, I know that I drew it along the x is equal to 1 line. So I can actually say our line of symmetry is when x is equal to 1. Now, this is just review, but what I'm going to talk about now is roots. What are roots? Well, roots actually have a few names, so let's start there. Roots are known as zeros or x-intercepts. Now, I think the word x-intercept is probably the easiest to understand, but we'll use all three of those words. That way, if I use them later, no one will be confused. Now, roots can be found in a number of ways. They can be found on a graph, a table, or you can actually solve the equation to find them. Now, today we're just going to be working on tables and graphs, so don't worry about the equation. That'll come later this week. Now, when we're talking about tables, how do we find our roots? Well, we know that roots must have y equal to 0. And what I mean is that when y is equal to 0, that coordinate pair is a root. So I'm going to go through our y column now, and I'm going to say anytime I see a 0, I'm going to stop and circle it. So if I follow our y column down, 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 I notice that we have a 0 right here and a 0 down here. So because there are zeros in the y column, I know that the pair that this 0 is part of is a root, and the pair that this 0 is part of is a root. So I can actually go ahead and remove those coordinate pairs. I can say that negative 1 comma 0 is a root, and 3 comma 0 is a root. So roots are really easy to find in tables because anytime you see y equals 0, or when there's a 0 in the y column, we know that that must be a root. Now, if we look over to the graph, and remember that this table belongs to this graph. If we look over to this graph, we find roots by asking, where does our graph intercept the x-axis? Well, the x-axis is right here, and I'm highlighting it in orange so you all can see it. But anytime our graph hits the x-axis, that point that it hits is actually a root. So if I follow the graph along to the x-axis, I manage to meet it in two different places. So I meet it once on the left right here, which the coordinate pair for that is negative 1 comma 0. And I meet again on the right here, which is the coordinate pair 3 comma 0. And because I know that my table and my graph are the same equation, I actually know for certain that the roots must be negative 1 comma 0, 3 comma 0. So when it says, what are the roots? All right, well, I found it in my table to be negative 1 comma 0, 3 comma 0, and I confirmed it with my graph. All right, so what I'd like you to do right now, we're going to go through number 2, and I want you to find the roots. So I would like you to stop this video for just a moment, find the roots of 2a and 2b, and once you think you're certain, go ahead and start this video again. All right, so you should have paused the video at this point, and you should have found the roots for 2a and 2b. Now, if you notice, there are no roots for, or there are no tables for 2a and 2b. So that means that we have to rely totally on the graph. Now, if I look at 2a, I'm going to follow the graph along, and anytime it hits this x-intercept, I know that that is a root. So I'm going to go ahead and follow this along, and notice I'm actually tracing it. All right. It hits once right here at negative 2 comma 0. And if I follow it along again, keep going, keep going, keep going, it actually hits one more time at positive 2 comma 0. So these are actually our two roots. Okay, now I'm going to do the same thing for 2b. If you haven't done 2b yet, pause it. Okay. And we're going to go through, and I'm going to do the same way. I'm going to trace it, and anytime I hit the x-intercept, or the x-axis, I'm going to go ahead and stop and record that. So negative 2 comma 0, and I'm going to keep going, going, to 4 comma 0. And now one thing you probably have recognized is that anytime we write a root, y equals 0. Roots always have y equals 0. Let me write that down. Roots always have y equals 0. Good. All right. So our last one that I'm going to do with you for today is number 3. Now, number 3 through 6, you're going to use the equation to fill out the table, graph the equation using the table, and find the roots. So I wrote 3 through 6 so that your tables show all of the roots and your graphs can be graphed correctly. So what we're going to do is, I noticed that I have this really nice equation right here. F of x equals x squared minus 5x plus 6. I have my table right here, and the x row has a whole bunch of values. So what I'm going to do is I'm actually going to take each one of those values and I'm going to plug it into my equation. Now this is going to take a little bit of a time, but we've done it before. I think you guys will be fine. So instead of x, I'm going to plug in our values, and I'm going to start with 0. So instead of saying f of x, I'm going to say f of 0 equals, instead of x squared, it's going to be 0 squared minus 5 times x, which is 0 plus 6. Well, 0 squared is 0. Negative 5 times 0 is 0. And the 6 gets carried down. Well, 0 plus 6 is simply 6. So I know when I plug in 0 for x, y is 6. So I want you to go ahead and plug in the rest of those numbers, 1, 2, 3, and 4. I'm going to go through it just like you are. So the next one, I guess I'll do in a slightly different color. Doing blue here. F of 1 equals x squared minus 5x plus 6. So x squared, 1 squared minus 5x, 5 times 1 plus 6. Well, 1 squared is simply 1. Minus 5 times 1 was simply minus 5 plus 6. Okay, 1 minus 5 is negative 4. Negative 4 plus 6 is positive 2. So I know when x is 1, y is 2. So I can go ahead and plug that one in and continue throughout this. So I'm going to go ahead and plug in 2. So Different color again. Let's choose red, I guess. F of 2 equals x squared, so 2 squared, minus 5x, 5 times 2, plus 6. 2 squared is simply 4. Negative 5 times 2 is negative 10. 6 gets carried down. 4 minus 10 is negative 6. Negative 6 plus 6 is 0. Now this is actually what I'm looking for. When I get the function to equal 0, I know that this number that I plugged in, 2, is part of my root. So when x is 2, y is 0. All right, I'm going to plug in 2 more numbers, finish this one up. So let's choose green for this one. Going to plug in 3. So f of 3, x squared, so 3 squared, minus 5 times x, 5 times 3, plus 6. 3 squared is 9. Negative 5 times 3 is minus 15. 6 gets carried down. 9 minus 15 is negative 6. Negative 6 plus 6 is also 0. And again, I plugged in a number and got 0. So I know that this is my second root. So when I plug in 3, I also get 0 for y. Okay, the last thing I'm going to do is plug in 4, and 4 is just to kind of finish this one off. So f of 4 is 4 squared minus 5 times 4 plus 6. Well, 4 squared is 16. Oops, what just happened? Sorry about that, everyone. Okay, negative 5 times, oh, I'm sorry, let's just start over. 4 squared is 16. Negative 5 times 4 is negative 20, and 6 gets carried down. 16 minus 20 is negative 4. 6 gets carried down, and negative 4 plus 6 is 2. So I know when f of x, when x is 4, y is 2. And I can actually go ahead and graph this now. Now that I have my entire thing done, I can go ahead and say, all right, well, let's just graph this. When x is 0, y is 6. So when x is 0, y is 6. When x is 1, y is 2. When x is 2, y is 0. When x is 3, y is 0. And when x is 4, y is 2. Now, I know this doesn't look like a quadratic, but this is in a U shape. The one point we're actually missing is our vertex because it starts to mirror really quickly. So what I'm going to do is I'm actually going to go ahead and graph this down. And once I hit this 2, I'm just going to go a little down and then come back up. Because notice the vertex is going to be below the roots. But this actually agrees with my table. So I know that our roots from the table are 2, 0, and 3, 0. And if I look at my graph, well, those are the only points that intersect with the y-axis. So I know that our roots are 2, 0, and 3, 0. So at this point, I'm done. All I've done is filled out the table, filled out the graph, and found my roots. So I'd like you to go ahead and try 4, 5, and 6 on your own. And I want you to go ahead and make sure that if you have any questions, please feel free to email me. And that's all of our lesson for today. So at this point, stay healthy, stay safe, and try and stay sane. All right. I will see you all later, and I enjoy talking to you as always. Take care, everyone.